Good afternoon, my YouTube viewers. It's Crystal here. I just want to give you another code review, and this code review is going to be on a Kaggle competition question. And basically, it's on the competition for volunteer retention prediction, and this is task number 1. So I was working on this last night and today. But unfortunately, with this competition question, you're only allowed 2 submissions per day. And I already did my 2 submissions. So I did some more work on it, but I can't submit it to be graded by Kaggle because I've already done my 2 submissions this day. But I'm going to go ahead and go over the code review for you anyway. And you can see what you like, you can see what you think of it. And it was hard. I was in the middle of the night working on it, and then I was really tired today where I go to earn money. I couldn't wait to get home so I could get home and take a nap, which is what I did. So I just had a nap, so I'm ready to do my code review. So we're going to do the problem statement. It says predict on volunteer retention in China during COVID-19. So you're going to predict on how many people are going to continue volunteering during the COVID-19 pandemic. So the first thing we're going to do is we're going to import the libraries that we're going to need. So we're going to import NumPy as NP, which creates NumPy arrays and also makes numeric computations. We're going to import pandas as PD, which creates the data frames and processes the data. We're going to from datetime import datetime. And then what that does is we're going to timestamp some of the data. We're going to import OS, which is going to go into the operating system and retrieve the files that we need to execute the program. We're going to import matplotlib.pyplot.splt, which is going to visualize the data. And we're going to import Seaborn as SNS, which is going to statistically visualize the data. We're also going to import sklearn. And what sklearn does is sklearn provides machine learning functionality. And so after we've imported the libraries that we're going to need, we're going to retrieve files using OS. So the files that we retrieved was retention test feet, sample submission retention.csv, retention GT train CSV, retention train feet. I would like to say that would they put sample submission retention CSV in the leaderboard, and it scored 97, and I scored about 111 on this before I amended it the second time, and I'm hoping that when I amended it the second time it would improve my score a little bit. So it is very difficult to get a decent score. But so those are the 4 CSV files that we're using. Okay, so now after we have retrieved the 4 CSV files, then what we want to do is we want to use pandas to read them into the system. So we're going to call them train, test, submission, and GT. So that's going to be, because it says retention GT train CSV. And it's sample submission here. And it's sample submission here that they put into the leaderboard, and it only scored a 97. So I did my best, and because I did my best, I decided I'm going to go ahead and do the code review because that was my best. And then if anybody can do better than what I've done and they want to show me their code, I really would appreciate it, because one of the things that I've noticed is that quite often people don't want to share their code. And I do share my code. I know that I pretty much have to share my code because I'm a content creator, but I do share my code. But a lot of people are not inclined to share in their code. And then so what happened is we're going to take the train file, and you can see that when we took the train file, you see that we've got this one column called unnamed 0, which is the same as the index. So that's not necessary. So we're just going to remove that first column by making train equals train.ilog brackets, square brackets, colon, comma, 1, colon, 12. And so that just uses all of the columns except for the first column. And we will have done the same thing with the test file as well. I will say that they made this competition very hard. It was a very hard competition to do, because another thing that they had on the train file, they had longitude and latitude, and then on the test file, I believe it was latitude and longitude. And so I had to correct all of that before I could get the program to work. So they were quite sneaky. So I just wanted to do a value count of user ID. So I wanted to see how many we had of each user ID, because I wasn't sure. So this was just a value count of user ID, and it doesn't really add anything to the program, but it was something that I did. And then what we did was we time-stamped the time, the task start time, the task end time. We time-stamped that. And then I created another column called train total task time equals pd.toNumeric train task time minus train task end time minus train task start time. And then we took the train GT, we merged train with GT so you could get the count in there. So let's see if we can find the count. So you've got your total task time, that's how long it took to complete a task, and then you've got your count. And the count is what we're going to be predicting on in the test set. We check for any null values. Fortunately, we don't have any null values to contend with. So now what we're going to do is we're going to create a pivot table, because the train file has to be the same as GT. So train PT means pivot table, equals train GT dot pivot table. Index equals user ID. Train PT dot reset index in place equals true. Train PT is organizer greater than 0 equals 1. Train PT drop task ID access equals 1 in place equals true. Train PT drop user ID access equals 1 in place equals true. Train PT, because you don't need the user ID, and the reason why you don't need the user ID is because it's because all of the rows are automatically indexed, so that's why you don't need it. So this is what the train PT looks like. It's 23,808 rows by 5 columns. You've got count is organizer, latitude, longitude, total task time. And this is GT, so it has to be 23808. You've got user ID and count. Over here, I just wanted to see how many unique values we had in each column, so we checked that out. Check train info, so you could see all the columns in train. And now we have test. So test, you can see here, we have longitude, latitude as the first. And then what we're going to do is we're going to remove the first column in the test file because you don't need it. And we want to check all the unique, number of unique values in each column just to see what that is. We checked for null values. Fortunately, we didn't have any null values to impute, so that was good. And then we did the same thing in the test file that we did in the train file. So train, we date time the test task start time, and we date timed the test task end time, and we created test total task time equals pd dot to numeric task end time minus test task start time. And this is your submission file. That's what they want to submit to Kaggle to be predicted on, and you can see it has 23809 rows by 2 columns, which is going to be your ID and your predicted. And then so TGT equals submission.copy. TGT user ID equals TGT ID. TGT drop ID access equals 1, in place equals true, TGT. So that's your TGT. So now we're going to take test GT and create test GT equals merge, PD merge, TGT test on user ID. So we've merged it together, which is going to be similar to the train file. And we're going to do some more work. We're going to say test PT, that's your pivot table, equals test GT dot pivot table, index user ID, comma, sort equals false. Test pivot dot reindex, index equals TGT index. Test PT dot reset index, in place equals true. Test PT is organizer greater than 0 equals 1. Test PT dot drop task ID axis equals 1, in place equals true. Test PT drop predicted axis equals 1, in place equals true. Test PT drop user ID axis equals 1, in place equals true. Column titles equals is organizer, latitude, longitude, total task time. DF reorder equals test PT, column titles. Test PT equals DF reorder, test PT. So now we have is organizer, latitude, longitude, total task time. And that's 23809 rows by 4 columns. Now what we want to do is we want to analyze the label. Target equals train PT dot pop count. So count is your label. And then we're going to use seaborn to create a histogram of it. So you can see there's your seaborn creating a histogram of it. We're going to define X and Y. Y is your target, and X is train PT, and X test is test PT. So you can see here we've got X is organizer, latitude, longitude, total task time, and X test is organizer, latitude, longitude, total task time. So they were actually quite sneaky. They put a lot of problems in the data set that had to be overcome before you could even get it to work. So that was one really sneaky thing they did. And then another sneaky thing they did was they only allow you to make 2 submissions a day. So this code that I'm going through, I can't even make a submission on it because I've already expended my 2 submissions a day. But I'm hoping that it would be better than the 111 that I previously got. So now, after we've defined our X and our Y variables, we're going to use sklearn's train test split function to split the data set up into training and validation sets. And then we're going to define our model. We used a random forest regressor in this instance. So model equals random forest regressor, max depth equals 2, random state equals 42, dot fit x train y train. And then we print the accuracy. It's only got a 4.7% accuracy, but it works on RMS, root mean square. So we're going to make predictions on the model with the validation set, and that's going to be ypred. And then we compare the ypred to the yval, and we get 62. And then here what we do is we make a chart and we plot the predicted values against the actual values. So you can see that. And then I created a histogram of ypred, so you can see what ypred looks like. And then I created a data frame that had the actual values against the predicted values, so you can see that. And then what I did was I predicted on the test set, so prediction equals model dot predict x test. I created a histogram of that, so you can see what the predictions look like. And then I prepared the submission. Submission predicted equals prediction. Submission to CSV equals submission.csv. Index equals false. Submission equals read CSV, submission CSV, submission. So you can see this is what I submitted to Kaggle. And the last thing that I worked on, I got 111, which isn't great, but as you can see from the competition question, I was the only one to even submit something, because it is a hard competition question. I'm not sure if I'm going to do the other one because it had 2 tasks. And I did the first task, and it has another task that you can do. And I'm not sure I'm going to do the next task because I'm a little bit peeved that it was so problematic to work on. But since I worked on it in the middle of the night, last night, the middle of the night today, I thought I wanted to give you a code review. If any of my readers know a better way to do this, then I certainly would be interested in hearing your views, because I just did mine the best way that I knew how to do it, and certainly I didn't get a perfect score, but I got a score. So I'm going to close this video now because we've been talking almost 20 minutes. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And if you want to be notified whenever I make a new video, please tap onto the bell button next to the notification button. And thank you for watching my video. I look forward to making more videos for you in the future.